Well, this video is for Math 95 for the rules of exponents. So let's talk about these before we start looking at some problems. I was just doing a video for Math 60 where we talked about the distributive property, and we had been doing the order of operations, which says do the most complex calculations first, then the next most complex, and then the least complex, okay? If you think about PEMDAS, this is your exponents, multiplication, division, addition, and subtraction, okay? And the reason why the distributive property works when you're having like 3 times x plus 2 is because multiplication in many ways can be conceptualized as repeated addition, right? So this is x plus 2 plus x plus 2 plus x plus 2, and there's your 3x plus 6. So that's where the distributive property comes from, and you can distribute multiplication and division across addition and subtraction. Okay, now exponents are essentially repeated multiplication, right? If you have x to the 4th power, that's x times x times x times x. Okay, so now because of that, if you have, let's say 3y squared to the 4th power, now that means 3y squared times 3y squared times 3y squared times 3y squared. And so that's 3 to the 4th power times y squared to the 4th power. Let's see, that's 81y to the 8th. So what I'm saying here is that you can distribute an exponent across multiplication or division. If you've got, x over 7 squared, that's going to be x squared over 49. Okay? Let's see here. I think, all right. So we'll come back to this in a minute. I just want to start laying out these rules of exponents. Okay. So, first rule of exponents says, I'm going to use the letter b for the base. B to the m power times b to the n power equals b to the m plus n. Okay? Let's say you've got x squared times x to the 5th. There's your x squared. There's your x to the 5th. How many times am I multiplying x by itself? 7 times, right? So that's why we do 2 plus 5, because that's how many x's are getting multiplied by themselves. Okay. So there's the first rule of exponents. Second rule of exponents says if you have b to the m over b to the n, that's b to the m minus n, right? So let's see, let's say we've got x to the 5th power over x cubed. So there's our x to the 5th on top. There's our x cubed on the bottom. And what happens is that these 3 x's cancel out 3 of the x's up on top, and we're left with 2 x's being multiplied together, which is x squared. So that's why we subtract the n from the n from the m, because that's how many x's are going to be left. All right. All right, so next we get the, what's essentially the distributive property here. We get b to the m power raised to the n power. That'll be b to the m times n, right? Let's say we've got x squared to the 5th power. Then there's x squared, x squared, x squared, x squared, and x squared. And now we come back to this rule right here, 2, 4, 6, 8, 10. That's x to the 10th power. I mean, I could do this. Each one of these is an x squared, and that means that now we have 10 of them. The easy way to do it is just to go 2 times 5 is 10. That's what this is saying right here. Let's see here. Oh, right, so now we get into the ones that I was just talking about a minute ago, and these are the distributive properties for exponents across multiplication and division, okay? So, let's see. And that one says if you've got AB raised to the n power, that's A to the n times B to the n. And that's what we were just talking about a minute ago. And the same thing is true of A over B raised to the n power. That's A to the n over B to the n power. All right, now we get the negative exponents. So this says B to the n power, negative powers, that's what I was saying, right? B to the negative n power is 1 over B to the n. Okay, why is that? Well, that brings us back to this one. So the example I gave for that, let's see, it was x to the 5th over x to the 3rd, right? So we had 5 x's on top, 3 x's on the bottom, canceled out 3 from the top, we were left with 2 x's on the top, which is x squared. What if they were reversed? What if we had x to the 3rd on the top and x to the 5th on the bottom? Okay, then we'd have x times x on top, and x times itself 5 times on the bottom. 3 of them would cancel out, and we'd be left with 1 over x squared. Okay, so now go back to this rule, though, that says if you want to calculate this or simplify this, you subtract m minus n. So let's do that. M is 3. N is 5, this is x to the 3 minus 5, which is x to the negative 2 power. So that says the notation x to the negative 2 represents 1 over x squared. Okay? The way I like to think of it is it says if you've got a negative exponent, that means it's in the wrong place. If you've got a negative exponent on top, that means it belongs in the bottom as a positive exponent. If you have a negative exponent on the bottom, let's see, let's say you've got 1 over x to the negative 4, well that means 1 over x to the 4th. And if you can remember back to your dividing fractions, you flip the bottom over and multiply. 1 times x to the 4th over 1 is x to the 4th power. So that's what I was saying. It's in the wrong place. If you've got a negative exponent in the bottom, move it to the top and make it positive. If you've got a negative exponent on the top, move it to the bottom, make it positive. So that's the negative exponent there. Okay. And the last one here is that if you've got a fraction, a over b raised to a negative power, move the b to the top, move the a to the bottom, make the exponent positive. And then go ahead and raise each one to that power. So, there are the rules of exponents. I guess I'll leave them up here. That's going to take up a lot of room on the board. But I'll just do the problems over here. And you'll have these rules. I don't expect you to memorize them. Okay? You'll have these rules on a formula sheet when you do the midterm and the final. And I encourage you to have it in front of you when you're taking the quiz. Okay? Let's see here. Oh, so the thing about these problems, there's a lot of different ways. There's a lot of choices that you can make about what to do when. Okay? It's sort of like if you want to drive to Portland, you can go out Highway 30 and go to Portland, you know. You can also go down the seaside and go over Highway 26. It'll take you to the same place. So that's the idea here. You need to choose which of these rules you're going to use, what order you're going to choose to use them in, but it should take you to the same place. Okay? And I'll try to talk about that a little bit as I go through the problems. So let's see here. Let's start with problem 2. We've got -3 y cubed, so that's getting squared, and then 2xy to the fourth. Okay, so the thing we want to do here is we want to simplify each of these separately, and then after we've done that, we'll go ahead and simplify what's left. So, this, we're looking at this property right here, right? We've got a couple of different things inside the parentheses. We're going to raise each one to that power. So, negative 3 squared. I'll go ahead and write this out for this first problem, but I'll typically skip this step when we look at the other problems. 2 to the fourth, x to the fourth, y to the fourth. Okay, so don't forget when you square a negative number, you get a positive number. 9, positive 9. Y cubed squared, here it is right here. Okay, and so that'll be y to the 6th power. Over here, 2 to the 4th power is 16. X to the 4th, y to the 4th. Okay, so now we're back to this rule right here. We've got an x to the 4th, we've got y to the 4th times y to the 6th, that makes y to the 10th, and then 9 times 16, you can use your calculator for that, it's 144. Alright, let's see. Not a whole lot of alternative methods, alternative ways to do this problem. These first couple problems are pretty straightforward. Let's see. So let's just keep moving here. So 2rs squared t to the 3rd, and then that's getting squared. And then we've got a negative 3 r squared s to the 3rd t, and that's getting raised to the 3rd power. Okay, well I'll go ahead and write this out like I did here for number 4 as well. So this will be 2 squared r squared s squared squared t to the 3rd squared. Then we'll have negative 3 to the 3rd, r squared to the 3rd, s cubed to the 3rd, and t to the 3rd power. Okay, so let's see, this will be 4r squared, s to the 4th, t to the 6th. So that's this rule right here. We're raising a power to a power, and so we have to multiply those two numbers. Negative 3 raised to the 3rd power is negative 27. R to the 6th, s to the 9th, t cubed. Okay, so now we need to multiply 4 times negative 27. I believe that's going to be negative 108. So let's double check that. There we go. So negative 108. Let's see. R squared times r to the 6th, r to the 8th power. S to the 4th, s to the 9th, s to the 13th. T to the 6th times t to the 3rd makes t to the 9th. Okay. Okay, now we've got some fraction problems with some canceling here. Negative 15 r to the 4th s cubed over 5 r to the 5th times s. And don't forget, this is s to the 1st power. Okay, so the coefficients, so I didn't mention this explicitly when we were doing those first two problems, but if you'll notice, I treated the coefficients separately from each variable, and I treated each variable separately from each other. And that's really the way, I think, a positive way to do these problems. Focus, so we're going to focus here, right? Negative 15 over 5, this cancels like a fraction. 5 into negative 15 goes negative 3 times. All right. Now, with the variables, we want to use, where are we? This property right here. Now, notice how the power of the r is bigger on the bottom than it is on the top. So if I were just to use this property right here, I would get an r to the -1 power. And there's nothing wrong with that. Okay? It's just that in the end, we're going to have to move that r to the bottom anyway, and so we might as well do that in the beginning. So what I'm saying here is this property you can also do 1 over b to the n minus m. Right? When we were talking about this a few minutes ago, I had, right, x to the 5th over x cubed was x squared. X to the 3rd over x to the 5th is 1 over x squared, which is the same as x to the -2. So I usually use this process rather than this one when I'm simplifying the problems. This is helpful to know that if you're seeing that negative exponent, that you should move it someplace. But what I'm saying here is that -3 is going to be on top, but we're going to have an r to the 1st on the bottom, right? 4 of these will cancel out 4 of these and leave us with 1 left over. Then this s will cancel out 1 of these, and that'll leave us with s squared on top, and there we go. Okay. Problem 10. 5 k to the 5th m to the 4th over -45 k to the 6th m to the 8th. All right. So, let's see here. 5 goes into -45 -9 times. All right. This k to the 5th here will cancel out 5 of these k's and leave us with k to the 1st power. This will cancel out 4 of these and leave us with m to the 4th. So on the bottom we've got -9k m to the 4th. And don't forget, when you have nothing left on top in a fraction, that means you have 1, right? If you have 3 over 6, when you cancel these, that's 1 over 2. So don't forget that 1. All right? When they're flipped over, it's not that big a deal, right? If you have 6 over 3, you can just say that's 2, or you can say that's 2 over 1. They're the same thing. All right? But if you've got the smaller number on the top, you're going to need a placeholder 1 for that. Okay. Let's see what else. All right, now we've got a combination of these two kinds of problems. So, problem 12, we've got 3ab squared raised to the 4th power, and then on the bottom, -12 a squared b to the 4th squared. Okay, so when it comes to the order of operations, you really need to apply these outside exponents. You can't just go and try to cancel the 3 with the 12 right away, okay? They're stuck inside those parentheses, and you've got to apply these exponents first before you look to do any canceling. So let's go ahead and do that, okay? So this is 3 to the 4th, which is 81, a to the 4th power, and then this will be b to the 8th power, right? When you're raising a power to a power, you multiply those exponents. 2 times 4 is 8. Okay, on the bottom, -12 squared, don't forget that's positive 144. This will be a to the 4th and b to the 8th power. Okay, well let's see, all the variables cancel out. A to the 4th cancels out a to the 4th, b to the 8th cancels out b to the 8th, and we're left with 81 over 144. And if we reduce that, let's see, 9 goes into 81 9 times, 9 into 144 goes in 16 times, and we end up with 9 over 16. Now, if you are in the habit of just turning fractions into decimals, you can do 81 divided by 144, and you'll see that this is 0.5625. If you're going to do that, don't round it off. It's a terminating decimal. Just go ahead and write down all the digits. Okay. Let's look at problem 14 here. Let's see. 18 m to the 4th n to the 5th over 27 m cubed n to the 6th, and that's all going to get squared. Okay. Now, in this problem, we could do the same thing we did here, which is apply this exponent first. But because of the way this problem is written, we have an option that we didn't have here. Remember, I was saying you can't just go and try and cancel the 3 and the 12 because they're in separate parentheses that have different exponents. These are all in the same parentheses. So we can go in and reduce everything inside here before we go and square. Okay? If you remember your order of operations, you work inside the parentheses first. Well, here's our parentheses. Let's work inside here first. Make these things smaller before we go to square them. Okay? So 9 goes into 18 twice. 9 goes into 27 3 times. This m to the 3rd cancels out 3 of these. Leaves us with m to the 1st, and same thing with the n's. This one cancels out 5 of these, leaves us with just a single n on the bottom. I'll rewrite it and make it a little cleaner. That's what's going to get squared. That's 4m squared over 9n squared, and there we go. Okay? Now, I think that's a little bit easier than squaring the 18 and the 27 and everything, and then looking to cancel things out. All right. Oh, now let's look at the next page here. Okay, problem 16. We start out -4, a to the 3rd, b to the -2, c squared. All right. So, before I start to do this problem, one important thing that I want to talk about is the difference between a negative in front of a coefficient versus a negative in front of an exponent. A negative in front of a coefficient has to do with the number line. Right? On the number line, all your positives are out here, all your negatives are out here. That's what this minus sign right here indicates that this 4 is to the left of 0. That's all it means. This negative sign means that this is in the wrong place. It belongs in the denominator. Okay? Now, you don't necessarily have to put it in the denominator first. We can wait until the end. Okay? I'll talk about that when I go through the problem. I'll do it in 2 different ways. But one thing I want to make clear is that this negative indicates that the 4 is to the left of 0. Has nothing to do with fractions. Okay? A lot of times people want to try to make this 1 over 4. That's not what's happening. You only do that if the negative is in the exponent. If the negative is in front of the number, it just means that it's a negative number. Okay? All right. So let's square all of these. All right? This is like those first problems that we were looking at. -4 squared, positive 16. A to the 3rd squared, a to the 6th. B to the -2 squared, b to the -4, and then c squared. And then all we really have to do is move that b to the bottom. And there we go. And there's nothing to cancel, really. Now, we could have started out by saying, let's see, we're going to do -4 a cubed c over b squared, and then we'll square that. And it'll take us to the same place, right? This will be 16 a to the 6th c squared over b to the 4th, and there we go. It's exactly the same thing. And so that's what I was saying about in the beginning of this, about how you have choices about what order you want to go in to do these things. Now, some things you don't have a choice, right? Like that problem we saw before where we had to raise these things to powers before we could look to cancel anything. But that wasn't the case here. Okay, let's keep going. Yes, problem 18. Problem 18 says 3m to the 4th n to the negative 3rd raised to the negative 4th power. Okay. Well, I'm going to go back to what I was doing with those first problems, where I raised each one of these separately to that power. 3 to the minus 4, m to the 4th to the minus 4, and n to the negative 3 to the negative 4 power. Okay. These are pretty straightforward. This is m to the minus 16, n to the positive 12, right? We multiply these exponents. This 3 to the minus 4 power, we need to go back to this property right here. This means 1 over 3 to the 4th power. And this m to the minus 16 means 1 over m to the 16th power. So there's what we've got. And so now we'll just calculate our 3 to the 4th power is 81. And there it is, n to the 12th over 81 m to the 16th power. Okay? We always want to express our answers with all positive exponents. All right. Now let's look at the next one. Problem 20. Okay. Negative 3. A, B, C. C raised to the negative 2. And that's all getting squared. 2a squared. B to the minus 3. And that's all getting cubed. Okay. I'll go ahead and write this out first separately. Negative 3 squared, a squared, b squared, c to the minus 2 squared. And then 2 to the 3rd, a squared to the 3rd, b to the negative 3 to the 3rd. So this will be 9, a squared, b squared, c to the minus 4. Then 8, a to the 6th, b to the minus 9. Now, again, you've got some choices. One thing you can do is just to multiply this all together. So we'll have 72, a squared and a to the 6th makes a to the 8th power. B squared and b to the negative 9, 2 and negative 9 make negative 7. And then c to the minus 4th. And then we'll move those negative exponents to the denominator. And there it is, 72, a to the 8th over b to the 7th, c to the 4th. Now, you could have started this problem by saying, well, I'm going to do this negative 3 ab over c squared, and square that. And then 2a squared over b cubed. Raise that to the 3rd power. So this is what I'm saying about, the choices that you have. You can apply these rules, like you can apply this rule first, right? This rule and this rule together is what I did first here. Or you can apply this rule first inside the parentheses if you choose to. Okay? And we'll end up with the same thing. Here's 9, a squared, b squared on top, c to the 4th on the bottom, 8, a to the 6th, b to the 9th. And then here's the b squared cancels with this to make b to the 7th. And I think that's it. 72, a to the 8th over c to the 4th, b to the 7th. Same thing. Okay. All right. Got a few more problems to look at. Let's see what we've got. Problem 22. A to the minus 5, b to the 3rd, ab minus fourth. I would recommend in doing problems like this, moving these negative exponents first. So we'll have b to the fourth on the top with the b to the third, and then that a to the negative fifth will come down to the bottom as a to the positive fifth. And that'll just give us b to the seventh on top, a to the sixth on the bottom. That one was relatively straightforward, but it's kind of illustrates this idea that it's really helpful to move these. You can still use these rules without moving them. It gets pretty tricky though. All right, let's see. Problem 24. 3 to the minus 1, u to the minus 1, v squared, 2, u to the third, v to the minus 4. So the first thing I'm going to do is move all the negative exponents, right? So the v squared is going to stay where it is. The 3 and the u go to the bottom. Let's see, along with the 2u to the third, stay where they are, and then that v to the minus fourth moves up on top as v to the positive fourth. And there we go, v to the sixth on top, 6u to the fourth on the bottom, and we're done. All right, let's see here. Problem 28. We've got n to the 8th power over 9m, and that's being raised to the negative 2 power. I'll do this problem two different ways. What I prefer to do is to flip this over. 9m over n to the 8th to the positive 2 power, and then we'll get 81 m squared over n to the 16th. So that's one way to go about doing this. The other thing you can do is just raise these things to the negative 2 power, right? You'll get n to the minus 16th on top, 9 to the minus 2, m to the minus 2 on the bottom. So now we've got to switch everything around. That's what this process does at the beginning, okay? So now we'll have 9 squared m squared on top, n to the 16th on the bottom, and then we're just one step away from the answer that we got doing it the other way. And neither one of these is better than the other, okay? I prefer this way, I find it easier. If you prefer this way and you find this easier, that's fine, there's nothing wrong with that. Okay, let's see here. 28. What do we want to do? All right, we've got three more problems here. Problem 30. We've got 4x to the minus 2, y to the minus 3, all being raised to the negative 2 power. Okay, now we've got a bunch of different choices about how to do this problem. Okay, and I'll show you a couple of them. First thing we can do is just raise everything to the negative 2 power. 4 to the negative 2, x to the positive 4, y to the positive 6. But then we've got to move that 4 squared down to the bottom. We'll have x to the 4th, y to the 6th, over 16. There's one way to go about doing it. Another thing you can do, simplify inside these parentheses first. This is going to be 4 over x squared y cubed to the negative 2 power. Then we can use this property right here to flip that fraction. This will be x squared y cubed over 4 to the positive 2 power. And now we just raise everything to the second power. X to the 4th, y to the 6th, over 16. That's what we got in the first place. Okay, so let's keep going here. Problem 32. 5x squared over 3x to the negative 4th, all squared. Well, I would move that x to the minus 4th. And like I was saying before, it doesn't matter usually, okay? So let's see, 5x squared, and then we'll put that x to the fourth up on top as a positive exponent. And now we've got 5x to the sixth over 3 all squared. So that's going to be 25x to the 12th over 9. All right, one last problem here. Problem 34. Yeah, when these things are in separate parentheses, I think that's when they're most complicated because you have to work with them separately. Okay, x to the minus 3y squared, negative 2xy to the minus 4th. Well, I think for this problem, I'm just going to apply all of these exponents. We'll talk about another way to approach this problem when I get done with it. But for starters, I'm just going to say, start out x to the positive 8th, y to the negative 12th on top. Down here, we'll get x to the 6th, y to the negative 4th, and then here, x to the negative 4th, y to the negative 4th. Now I'm going to move everything that has a negative exponent, which is most of these. Okay? That x to the 8th will stay where it is. That x to the 6th will stay where it is. The rest of these go to the top, y to the 4th, x to the 4th, y to the 4th, and this y to the minus 12th comes down to the bottom. All right, so now what? What do we have here? X to the 12th on top, y to the 8th, and on the bottom, x to the 6th, y to the 12th. So we get x to the 6th on top, y to the 4th on the bottom, and it is kind of a lot of work, but isn't this a lot simpler than what we started with? You could have moved these negative exponents to begin with, you know. You could have said, well, let's move these to the top and move that one to the bottom, and that would have given you x to the minus 3y squared to the positive 2, xy to the positive 4. This one would have been x to the minus 2y cubed to the positive 4th power. So that's another way you could have approached this. I'll go ahead and finish this off so you can see that we wind up with the same thing. X to the negative 8th, y to the 12th. And then we have to swap these two. And I think after we do that, we just end up with this. Okay? And that'll take us to the same answer there. All right. So these things can get kind of complex. I think it's important not to be overwhelmed by something that looks really complicated. Work on it, pick it apart. If you can break things down into smaller pieces, often they're a little bit easier. Okay? All right. If you have any questions with this, please let me know. Thanks.